Section 8.6 is all about bringing the conic sections together, and we will be doing a lot of completing the square. So these are all the formulas for our different conic sections. These are on our formula sheet, but these are all the different variations that we have. So what we want to do is we want to write the equation in standard form, and then once it's in standard form, state whether the graph of the equation is a parabola, circle, ellipse, or hyperbola, and then graph it. Take a minute and put this in standard form. Now at this point, I know that the curve is an ellipse because I'm adding my two x's and y's together, but my y has a coefficient in front of it, so that means it's an ellipse. So what I'm going to do is I'm going to divide through by 16. So then I get x minus 3 squared over 16 plus y squared over 4 is going to equal 1. So then my center is at 3, 0. It's a horizontal because the x is above the a term. The a term is 4, and my b term is 2. So take a minute and graph that ellipse. Now that's what the graph of the ellipse should look like. Example 2a, it's all the same directions, except we will not worry about graphing. So take a minute and try completing the square on your own. This is the equation that we get after we complete the square. At this point, I know that the curve is a hyperbola because of the subtraction. So in order to get it in perfect hyperbola form, I need to divide by 6. So it's y minus 2 squared over 6 minus x plus 1 squared over 3 equals 1. Example 2b, same directions, so take a minute and complete your square. Now, after we complete the square, we get this equation. Now, this equation is actually going to turn out to be a circle. Even though I have a term in front of the x and the y, since they're the same, I can divide through by that term. So then I get x plus 5/2 squared plus y minus 3/2 squared equals 1. And the final equation. Take a minute and complete the square for this problem. This will be our last example. Okay, in the final example, it's clear that this is a parabola because there's only one squared term. So what we're going to do, since it's y squared, I move all the y's to one side and then the x and the constant to the other. Then I go through and complete the square. I kind of ignore the 3x until the very, very end, once 3x is by itself, and then I just do divided by 3. So I get that x equals 1/3 y plus 3 squared plus 3.